Cool. So we can evaluate limits using the one-sided limit laws. So I want to remind you of what the graph of the square root function looks like. So when you look at the graph of the square root function, the graph of the square root function looks like this. Right, so this is y is equal to the square root of x. And then if I have the x minus 2 inside the square root, how does that transform my graph? Does my graph go up 2? Does it go down 2? Does it go left 2? Does it go right 2? What do you think this x minus 2 inside the square root does? You can either unmute yourself or type in the chat box. It goes right 2, that's correct. Because it's inside the square root function, that's a horizontal action. And minus 2 makes it go to the right. So then when I go to graph this guy now, or draw a quick sketch, not really a graph, but this guy looks like this. So there's like 1, 2, there's 0. And then my graph looks like this. This is y is equal to square root of x minus 2, like that. Okay. So when we take a look at this as x goes to 2 from the positive side, what do you guys think that answer is going to be? Well, we're coming from the right side over here, so it's coming like this, it's coming down, and I'm looking at the y values, right? So when I look at the y values, where does it look like the y values are going to go? Looks like the y values are going to go to the y value of 0. So this one-sided limit is 0. Is there any questions about that? Now let's say we approach 2 from the negative side. If I approach 2 from the negative side, I'm coming this way. So can you guys see that the function's not defined here? So the limit doesn't exist, doesn't exist, doesn't exist, doesn't exist, doesn't exist, doesn't exist, doesn't exist. So when I come this way, the whole time, it looks like my limit does not exist. Okay. So that's what I mean by just using a one-sided limit. You're really worrying about the domain. So I'll say coming from the left side of 2. The function square root of x minus 2 is undefined. So this means that the limit does not exist. Okay. If this was a cube root actually you have no problem. So let me just make a quick comment here. If you looked at something like the cube root graph looks more like this. This is y is equal to the cube root of x, or x to the 1/3 power. So when you have that situation, you're okay. It's the even indexed roots that you worry about the domain. Okay. So odd index, no problem. Even index, you worry about the domain. You got to come from the proper side. All right. All right, cool. So I don't think I have any classwork of that. I do not. So let's take a look at these piecewise defined functions over here. Okay. So when we have this piecewise defined function, remember our function is defined differently on different pieces. Okay. So what this example 7 is about is it's really about, are you using the right definition of f when you evaluate the two one-sided limits? So let's say I'm trying to calculate the limit as x approaches 2 from the negative side. Then I can really write this as the limit as x approaches 2 from the negative side. Which of these two functions should I use? Should I use the top function or should I use the bottom function? What do you think? Luciano says the top, and I agree. So we're going to put in this 4x plus 1 over here like this. So if I were to draw a little number line to try to represent the situation, so let's say it looks like this. I draw a little number line, and I'm going to put the 2 over here. And then if you're to the left side of 2, your function is 4x plus 1. If you're on the right side of 2, your function is x minus 3 squared. Okay. So now how do I evaluate this limit? Three-word phrase. First word begins with a D. That's right, we're going to use the direct substitution property because there's no problem with the domain. So I plug in the 2 and I get an answer of 9. Is there any questions about that? No questions. All right. Let's do part B. I calculate the limit as x approaches 2 from the positive side. When I come from the positive side, that means I'm coming this way, right? So how is my function defined on this piece? On this piece, it's defined to be this guy. So my function is going to be x minus 3 squared like this. Okay. So you're probably saying in your head, oh, can I use the direct substitution property here? And the answer is yes. I have no zeros in the denominator. I have no negatives under even indexed root. I could just plug it in. And when I plug it in, I get negative 1 squared, which is equal to 1. So here's the $1 million question, folks. What is your answer for part C? What do you think? You can type your answer in the chat box or unmute yourself. Good, Jasper. Good. This one does not exist. And why does it not exist?
Because you can have 2 points for a limit.
I would say you're correct. I would say the limit is different from the left and as it is from the right. So you're right, we get 2 different points. I just would say, oh, you come from the left, you come from the right, you get 2 different limits. So does not exist. Limit from left is not equal to the limit from the right. Okay.
So if, like, let's say A and B were equal to each other, then C would be also the same answer?
Correct, for sure. That's right. Mm-hmm. So in this particular case, if we were to draw a picture, it's almost like, oh, here you have the number 2. And when you're coming this way, coming in one direction, it's going to 1. You come from the other direction. Oh, wait, I have the wrong direction. Sorry. You come from one direction, you're getting 1. Come from the other direction, you're getting a 9. So there's like a gap there. So now they're not going to the same thing. Okay. All right. So really, Number 8 is one that I'm going to put a little star next to. Why did I put a star next to this? This is a very classical type of problem that many students have some difficulty with. So I want to say a few words first. So when you look at an absolute value function, like absolute value of x, this is really a piecewise defined function. So ignore the x minus 1 first. Let's just look at this guy first. Okay. So when you think about what absolute value does, absolute value, it's going to spit out the same number if the number is already positive. But if the number is negative, it's going to turn it into a positive number, right? So if you have absolute value of 7, that's just equal to 7. But if you have absolute value of -5, that's going to be 5, right? Absolute value means make it positive. So the way that we define absolute value is if x is already non-negative, the output's going to be x. But if x is negative, how do you turn a negative number into a positive number? Well, when you multiply by -1, that makes a negative number into a positive number. So I'm going to put a negative x here. Does that make sense to everybody? So that's not the question that I care about. The one that I care about is absolute value of x minus 1. So what I'm going to do is anywhere I see an x, I'm going to substitute in an x minus 1. So then this means if I want absolute value of x minus 1, that's going to be equal to, I'm just going to put a x minus 1 here, negative x minus 1 there. This is if x minus 1 is greater than or equal to 0. And this is if x minus 1 is less than 0. All I did was substitute. Does that make sense to everybody? Any questions? So I want to simplify these expressions over here. I just want to isolate the x. So I don't want to rewrite this whole thing. I guess I could rewrite the whole thing. Fine, I'll rewrite the whole thing. Let's just rewrite it. So that means if I added 1 to both sides, I'm going to get, this is when x is greater than or equal to 1. And this is when x is less than 1. So this here is the piecewise function that I'm going to work with. And now I'm just going to do the same thing I did for example 7. Okay. So let's calculate this. So I'm going to take the limit as x goes to 1 from the positive side, absolute value of x minus 1 over x minus 1. If I'm coming from the positive side, am I using the top one or the bottom one? What do you think? Top or bottom? That's right, top. Because when you're coming from the right side of 1, the numbers are bigger than 1. That means you gotta use the top guy. So this becomes x minus 1. Sorry. The limit as x goes to 1 of x minus 1 over x minus 1. And that's just equal to 1, right? Because this is the same term, they cancel each other out. So you get 1. Is there any questions about that? All right. Let's take a look at the next one. So if I take the limit as x goes to 1 from the negative side, which one do I want to use? Do you want to use the top one or the bottom one? Well, this time, because I'm plugging in numbers like 0.999, those are numbers that are less than 1. I should use this bottom guy. So that's going to be negative x minus 1 like this. And the x minus 1 terms factors can cancel out. So in this case, I get negative 1. So you come from one direction, you get 1. You come from the other direction, you get negative 1. So now if I ask you, what's the limit as x goes to 1 of absolute value of x minus 1 over x minus 1 like this? What would you say that limit was equal to, my friends? Good, does not exist. For the same reasons as above. The limit from the left is not equal to the limit from the right. So, good. Let me change the color of this because I use this. So let me change that to green. That's what I use to actually solve this problem. All right. All right, folks. Why don't you guys try number 5?